Welcome to a lesson on the law of cosines. In this video, we will be looking at how we can use the law of cosine to solve triangles. So again, we'll be given parts of the measures of triangles, and we'll have to figure out how to find the remaining values of the triangle. And then we'll also introduce another formula that we can use to find the area of a triangle. Which, if you remember, we looked at the last lesson, we looked at law of sines. Which law of sines, we kind of talked about how law of sines gave us a relationship in the proportionality. So the largest angle would have the longest side, right? The shortest angle would have the shortest side. So there's kind of this proportion involved in triangles. And so using those proportions, we could find the missing values. And we had some categorizations, right? Remember, we had the angle, side angle, and side angle, and then we had side angle. So we had those different situations that we had to look at, and we will have the same thing here with law of cosines. It's just a little easier. We only have two that we actually have to look at. So first, let's just define law of cosine. Again, if law of sines, we thought in this terms of proportion, law of cosine you can maybe think of as an extension of the Pythagorean theorem. The law of cosine has three formulas, really three versions of the same thing. So I'm going to really focus just on this third version. So if we have c squared, so again we have this triangle ABC, and then we have opposite sides ABC, so each side is opposite its corresponding angle. The third equation says that if we are trying to find the length of side C, we could use c squared equals a squared plus b squared, which, if you remember, that is the Pythagorean theorem. We then just have to subtract off minus 2ab times the cosine of c. Now, this is not a right triangle. If it was a right triangle, we could just use the Pythagorean theorem to find the different sides. And so because it's not a right triangle, we don't have an opposite or a hypotenuse or an adjacent side. We just have three sides of our triangle. But we can relate them to one another. If we know angle C, we can use angle C to find side C. And we can use angle B to find side B, and we can use angle A to find side A. And whichever angle, whichever side you're not trying to find, whichever side is not over here on the left side, then it's going to be the other two squared added together minus 2 times those other two. So if we're trying to find A, you're going to have b squared plus c squared and then 2bc. If you're trying to find B, it's a and c, so a and c. And if you're trying to find c, again, it's ab and ab. So as long as you remember, if the side that's by itself on the one side of the equation has to match the angle in your cosine, okay? So again, it almost looks like it's an extension of the Pythagorean theorem, but it still plays out based on the symmetries, on the proportions that we saw in our triangles. So with law of sines, we had two types, two classifications that we had to worry about. Now we only have, we had three. Now we only have two classifications. So again, law of sines, you had side angle, and angle side angle, and then side angle. Now we just have two. The first one is side angle side. So again, we have a triangle where we're given the measure of the length of two of the sides. So in this case, maybe we have a triangle with two sides that are 8 and 15 units long, and then we have an angle, and specifically the angle is in between those two sides. So say it's a 30-degree angle. Again, this is different than the side angle that we had with law of sines because of the location of the angle. The angle is located in between the two sides. The sides are the edges of that angle, and it makes life so much easier if that's the case. Because if you remember, if the angle was either of the other two, we had side angle, which we refer to that as the ambiguous case, and we had a whole lot of other stuff that we had to figure out. Did you have one or two solutions, that sort of thing? We don't have to worry about that here. Okay, this is going to be very straightforward. The second option that we're going to look at is side. So if you knew the measure of all three sides of the triangle, then we can figure out all three angles. Okay, and again, just using the law of cosines. The one classification of all the sort of permutations of the sides and angles that we do not have, that you can't actually come up with a specific triangle for, is if you're given angle, angle, angle. Because with angle, 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 the sides can be as long as they want. There's no restriction on the sides. So we only have these two types of triangles for law of cosines. And sometimes you may see other people do this if you look at some other textbooks or other lessons or other videos online. But I would strongly encourage you, when you start a problem using law of cosines, you finish it with law of cosine. So in other words, don't start with law of cosine and then switch. Once you get like halfway through, don't switch to doing law of sines. Okay, again, you might see some people do it that way, but I would just, if you start with law of cosines, finish it to the end using law of cosines, because if you try doing law of sines, you can potentially step yourself back into using the side-side angle, and we don't want to deal with ambiguous case anymore. All right, so let's go ahead and look at a couple problems. So we want to solve a triangle. We are given side C, or sorry, angle C is 45 degrees, side B is 10, and side A is 15. And again, we can draw kind of whatever triangle we want. I'll just kind of do a triangle similar to what we were looking at in our last lesson. So it's triangle, I'll say triangle ABC, where A is bottom left, B is bottom right, and angle C is the top angle. So side A is opposite angle A, side B is opposite side B, and side C is opposite angle C. And so we're told that angle C is 45 degrees. We are told side B is 10, and side A is 15. So again, same thing we did with law of sines. The first thing you want to do is check what kind of triangle is it. Okay, and this is more important now than it was last time, because we're dealing with both laws now, so we need to make sure we're picking the right law. So you want to use the right tool for the right job here. So looking at what we're given, we are given two sides, A and B, and then we're given an angle, and thankfully that angle is the angle between the two sides. So angle C is the angle that's between sides A and B. So because that's true, that means we are looking at two sides and the angle in between. We have side, angle, side, and that is law of cosine. So again, it's very important that you check that out first, because when you get into the homework and other exercise problems, it may not tell you use law of cosines or use law of sines. It may just say solve this triangle, and you have to figure out which law am I supposed to use. Okay, so to go ahead and solve the triangle means we want to find all of the missing parts. So why couldn't we just use law of sines here? Just maybe something real quick. So if we wanted to do a law of sines, remember that was sine of A over A is equal to sine of B over B, and that is equal to the sine of C over C. If we plug our values in there, I don't know angle A, so we'll just have the sine of A, but I do know side A is 15. I don't know angle B, but I do know side B is 10. And then we're going to have the sine of angle C, which is 45 degrees, but I don't know side C. So you may not realize this right off the bat, but the problem with using law of sines is that I don't have any pair of angle and sides at this point. Okay, and in order for us to solve a proportion, so say we tried to use the A's and the B's, right? I have two variables. I have an angle A and an angle B. Well, maybe so, and we can't solve for both of those. You only can solve for one. Well, maybe we wanted to do the B's and the C's. Well, I have angle B, but I have side C. So in any pair that I match these up with, I'm always going to have two unknowns, okay? And so because there's two unknowns, I can't use the law of sine. Right? I don't have enough information to solve any of those equations. So that's where a law of cosine comes into play. We're given angle C, we're given sides A and B, and since we're given angle C, we need to go ahead and use the law of cosines that used C. All right, so again, remember, if we have the cosine of angle C, which side goes over here on the left side of the equation? Well, it has to match. So if this is cosine of C, then over here we have C squared. So C squared equals A squared plus B squared minus 2 times AB times the sine of cosine, times the cosine of C. So again, the C's are on the outside of the equation, so it's the C squared on the left, we got the cosine of C on the right, and then everything in the middle is the A and the B. It'll always be the same format, just the letters may jumble around a little bit. So let's go ahead and put our values in here. Side C we're trying to solve, so C squared equals 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 45 degrees. And this, you could pretty much just crunch it out on a calculator if you want. We'll kind of do it by hand here though. 15 squared is 225. 10 squared is 100. Minus 2 times 15 is 30, and 30 times 10 is 300, and then we have the cosine of 45 degrees. So we have C squared is equal to 225, and 100 would be 325 minus 300. And cosine of 45, this is actually a nice unit circle angle. Cosine of 45 would be a square root of 2 over 2. So that gives me C squared is equal to 325 minus, and then the 300 and the 2 reduce down, so it's cutting it the 300 in half. So 150 square root of 2. A common mistake that people make around at this point is that they combine the 325 and the 300 to get a 25. You can't do that though, because this 300 is being multiplied by the cosine, by the root 2 over 2, and so they're not like terms, so you can't combine these. You're stuck leaving them as they are. So to find C, we're going to have to take the square root of both sides. So it's going to be the square root of 325 minus 150 square root of 2. Which, using a calculator, that comes out to be approximately 10.62. Okay, and again, that's rounded to 2 decimals. So we know side C here is 10.62. All right, so we now know, we actually have all 3 sides. All we need to do is find our 2 angles. And so to find one of the angles, again, you might be tempted now to jump back to using the law of sines, because we now have both values for C's, both of our side and angle C's. But I'm going to really encourage you not to do that. It can make solving it for it easier, but it also opens up the possibility of dealing with a side-side angle, an ambiguous case, and we just don't want to do that here. Because you have to figure out, if there are 2 solutions, which of those 2 solutions is the correct one. So let's just use the law of cosine again. So, and again, I like to go alphabetical. Let's solve for angle A. So to use angle A, that means I need to use side A. So we're going to have A squared, and then the other sides go on the other side of the equation. So B squared plus C squared minus 2 times BC times the cosine of A. Okay, so let's go ahead and plug our numbers in there and then solve it for A. So side A is 15, so 15 squared. That will equal 10 squared plus C, and side C was 10.62 squared minus 2 times 10 times 10.62 times the cosine of A. Okay, so we need to solve this for A, which means we first need to solve it for the cosine. So we're going to have to go ahead and, I'm not going to simplify this quite as cleanly as I did the last one because we have this decimal in here, but so let's subtract the 10 squared over and then the 10.62 squared over. So we're going to have 15 squared minus 10 squared and then minus 10.62 squared, which equals a negative 2 times 10 times the 10.62 and then the cosine of A. So to get cosine by itself, we're going to divide everything over. So we're going to have 15 squared minus 10 squared minus 10.62 squared. All of that is divided by a negative 2 times a 10, and then a 10 times a 10.62, and that is equal to the cosine of A. And so how do we find A? How do you get rid of a cosine? You have to do an inverse cosine. So this whole fraction on the left side, you can compute that pretty easily with the calculator. Just make sure you have parentheses around the numerator and the denominator. So A, but I'm going to go ahead and write the whole thing out. A is going to equal the inverse cosine of 15 squared minus 10 squared minus 10.62 squared all over a negative 2 times 10 times a 10.62. And again, we can compute that using our calculator. You just need to make sure that you are in degree mode before you do that. And that gives us 93.27 degrees. Okay, so it's actually an obtuse angle, which I think would have been a problem had you tried to use law of sines. All right, so we now have angle A. So we know that's 93.27 degrees. So the only thing that's left for us to do is to find angle B. And in this, we don't even have to do law of cosines or law of sines at this point. We can go back to sort of the basic geometry that the sum of our three angles has to equal 180 degrees. So we have 93.27 degrees plus B plus 45 degrees must equal 180 degrees, which means B will equal 41.73 degrees. And again, that's just rounded to 2 decimals using my calculator. Okay, so again, just to summarize, draw your triangle out, label the sides that you're given, and determine what type of triangle it is. So is it side angle side, or is it side side angle, or is it angle side angle? Once you know the type of triangle, make sure you know what rule that means. So again, in this case, side angle side meant we are dealing with cosine. So if you make sure you know what rule you're using, and then for cosine, find one of the missing, in this example, we had to find a missing side, and then we use that side to find a missing angle, and then once we found the missing angle, we were able to find the third angle because they all add up to 180 degrees. All right, let's try one more here. So we have the same setup as we did before. We have triangle ABC. Again, I'll put A in the bottom left corner, B in the bottom right, and C sort of up top. Side A is 10, side B is 15, and side C is 12. So again, in this example, we know all 3 sides. That turns out to be a side, side, side. And side, side, side means we're using the law of cosine. So again, that should always be your first process. Draw the picture, label your sides or your angles that you're given, and then figure out the rule, figure out the type of triangle so you can figure out the rule that you need to use. So again, this is side, 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 so it is a law of cosine problem. So because it's law of cosine and we're given all 3 sides, we need to find the angles. That's all that's left. So we're going to use our law of cosines twice to find our missing angles, and then we can use the fact that all three angles add up to 180 degrees. So I'll just go alphabetical again. So a squared has to equal b squared plus c squared minus 2b times c, and then the cosine of angle A. So we'll go ahead and we'll find angle A first, and then we're going to need to find angle B. Again, I'm just going to go alphabetical. So we would have b squared is equal to a squared plus c squared minus 2 times a times c times the cosine of angle B. So if we can find angle A and angle B, then we can really easily find angle C. So before I plug numbers in, let me just do the algebra here. So if we go back to our equation with A, we need to solve for angle A, which means we need to solve for the cosine. So that means we need to subtract the b squared and the c squared over. So we're going to have a squared minus b squared minus c squared. That'll equal a negative 2 times bc times the cosine of A. We then need to divide the 2bc over. So we're going to have a squared minus b squared minus c squared divided by negative 2bc, and that's equal to the cosine of A. And so to get cosine, or to get rid of the cosine, we got to take the inverse cosine. So A is going to equal the inverse cosine of this fraction. So a squared minus b squared minus c squared all over a negative 2 times b times c. And if we do the same thing with the equation with the b, it'll turn out to be pretty much the same process. So I'm going to skip through all the algebra there and just kind of match up our letters. So b will equal the inverse cosine of b squared minus a squared minus c squared all over a negative 2 times a times c. Okay, and a very similar process would work if you had to do it for angle C. So we can go back to both of these equations, plug the side lengths for A, B, and C into both of these equations, compute them, and then we'll have our two angles. So angle A will equal the inverse cosine of 10 squared minus 15 squared minus 12 squared. And all of that is over a negative 2 times 15 times 12. Which, using a calculator, that gives us about 41.65 degrees. Okay, so there's angle A. And we can do the same thing for B. So B is going to equal the inverse cosine of 15 squared minus 10 squared minus 12 squared over a negative 2 times 10 times 12. And that turns out to be 85.46 degrees. Again, those are both rounded to 2 decimal places. So we have found angles A and B. To find angle C, we could do the exact same process and set up our law of sines equation. Instead, we can use sort of the easier method that A plus B plus C is 180 degrees. So A is going to be 41.65 degrees plus 85.46 degrees plus C has to equal 180 degrees. And solving for C, we get 52.89 degrees. Okay, so we were given three sides of a triangle, which is a side, 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 which is the law of cosines. We had to use the law of cosine equation twice to find two of the angles, and then once we found those two, we could easily find the third. All right, last thing I want us to look at is finding area of a triangle. So at this point, you should already have two formulas that you're familiar with for areas of a triangle. So area equals 1/2 base times height. That's just your normal definition or normal formula. Again, but you have to have the perpendicular base and height. And then last time we looked at area equals 1/2 A times B times the sine of theta. And again, the key here was that you had to have two sides and the angle in between them. Okay, so depending on information you have, what information about the triangle you're given, one of those would be a little easier to use than the other. So a third method that we have defining the area of a triangle uses Heron's formula. Or sometimes you may hear it, you may see it as hero, so without the n. So hero or Heron's formula. It's a little bit more involved to some extent. There's two things you actually have to compute, but it's not real hard. And so Heron's formula allows us to compute the area of a triangle if we're given just the sides. So we don't have any angle and the sides, none of the sides are perpendicular to each other. So according to this formula, the area of the triangle will equal the square root of the quantity s times s minus a times s minus b times s minus c. So it's the square root of all of those products. So what is this s? The s, you can refer to it maybe as the semi-perimeter. It's half of the perimeter. So if you remember, perimeter of a shape means you just add up the sides. So s is equal to a plus b plus c, that's the perimeter, but then divided by 2. Okay, so it's generally really easy to compute. Let's go ahead and look at an example. So let's say we want to find the area of a triangle, and we're given the length of 10 meters, 18 meters, and 24 meters. Okay, so again, we could use, we could try and sit here and use law of cosine to find one of the angles, and if we did that, then we could use our second formula that we had, the AB sine theta. We could try and figure out a perpendicular height in here and use that to use your normal formula, but again, those are just going to take a lot of extra work that we don't need. So to use Heron's formula, we first need to find the semi-perimeter, so S is equal, and it's half of a plus b plus c, so we have 10 plus 18 plus 24, and that's divided by 2. And 10 plus 18 plus 24, that's 10, that's 28, and so that would be 52. So we have 52 over 2, which is 26. Now that we have the semi-perimeter, we can go ahead and plug it into our area formula. So area is equal, and I'll write the square root here in a second, but area is equal to the square root of S, which is 26, times 26 minus 10, times 26 minus 18, and then times 26 minus 24. And again, it is the square root of all of that. So if we simplify that a little bit, we're going to have the square root of 26 times 16 times an 8, and then times a 2, which is the square root of 6656, which is 16 times the square root of 26, or about 81.5 5, 8.